A 3.44 kilogram block located on a horizontal frictionless floor is pulled by a cord that exerts a force of F equals 11.2 newtons at an angle theta equals 24 degrees above the horizontal as shown. What is the magnitude of the acceleration of the block when the force is applied? So we know from Newton's second law that the net force acting in any direction on an object is equal to its mass times its acceleration. So this force is a vector that can be divided into components. So this initial force is equal to 11.2 newtons, but there's a y component to this force and an x component of this force. And this block is equal to 3.44 kilograms. So we can write Newton's second law out. F net in any direction. Let's choose the x direction. So F net, the sum of the forces acting in the x direction, is equal to the mass times the acceleration. So to solve for the x component of the force, we can use trigonometric rules and SOHCAHTOA. So F net x. So for this one, we can look at it as a right triangle, and we can use sine, cosine, tangent. So if this angle is equal to 24 and we want the side adjacent to the angle, we can use cosine. Cosine of theta will be equal to the side adjacent over the hypotenuse. So multiply the hypotenuse over to the other side so we can get just F, the force in the x direction, and we get 11.2 times the cosine of theta, which is 24 degrees. So, and F net x will be equal to this since this is a horizontal frictionless floor and the only force acting on the mass is this rope that's pulling it. So we can put that into the calculator and we get 10.2317 newtons as the force in the x direction. So we can rearrange this first equation to equal acceleration. Acceleration equals F net in the x direction divided by mass. So F net in the x direction we found to be 10.2317 divided by the mass, which they told us in the problem to be 3.44 kilograms. And we can just divide that in our calculator to get 2.9743 meters per second squared as the acceleration of the system when the force is applied. The next question asks for the horizontal speed of the block 4.1 seconds after it starts moving. So we can use the acceleration formula to solve for this. Acceleration is equal to the change in velocity over the change in time. And in the last problem we figured out the acceleration to be 2.9743. And we can set that equal to the velocity, which we have to find, divided by the time, which they gave us in the problem to be 4.1 seconds. So velocity will be equal to 2.9743 times 4.1, and we can put that into the calculator to get the velocity to equal 12.1946 meters per second, 4.1 seconds after the block starts moving. Next, we have to figure out the magnitude of the normal force acting on the block when the force F is acting on it. So the formula for the normal force is equal to mg minus F sine theta. So mg is the weight of the block and the force is the 11.2 Newton force that's pulling the block to the right, and theta is the angle above the horizontal which the force is pulling. So mg 3.44 times 9.8 minus the force is 11.2 newtons times the sine of 24 degrees. So 3.44 times 9.8 is equal to 33.712, and 11.2 times the sine of 24 is equal to 4.5555, and 33.712 minus 4.5555 is equal to 29.157 newtons. This is the normal force that's acting on the block when the rope is pulling the block. If instead the floor has a coefficient of kinetic friction to equal 0.04, what is the magnitude of the frictional force on the block when the block is moving? So the formula for force of friction equals the product of the coefficient of kinetic friction and the normal force. So the coefficient of kinetic friction from the problem is 0.04, and the normal force we figured out in the last problem to be 29.157 newtons. And we can just multiply that in the calculator to get 1.1663 newtons as the frictional force acting on this block. Now, what is the magnitude of the acceleration of the block when friction is being considered? So we can use the same setup as we used in the very first problem, which was A is equal to the F net in the x direction divided by the mass. So acceleration we have to find when the friction is being considered. So this time the net force acting in the x direction will actually be the x component of the force acting on the box minus the frictional force. So in the first problem we figured out 11.2 times the cosine of 24 is equal to 10.2317. And we have to subtract the force of friction, which we found just here, 1.1663, and divide all of this by the mass, which is 3.44 kilograms. And so we can put this all into the calculator and solve for acceleration to equal 2.6353 meters per second squared.